Good evening, guys. I'm Chris, and welcome back to this Wednesday's episode of Rift Apps. The only downside to drilling and punching your own chassis is the deburring of the holes afterwards. Now, the ones on the base are easy because you can just come in from this side with your step drill bit, and they always clean up really nicely. But the ones on the side just take forever. And it's really messy, and you always cut your fingers, so it's not a fun job. Right, Q&A time. Before we start though, a bit of housekeeping. We did it. Somehow, I've hit 5,000 subscribers. Now, in the grand scheme of YouTube, I know that's nothing. I know it's not a lot. But for my little channel, which I put very little effort into, let's be honest. You know, I'm not a YouTuber. I just film what I'm doing in the workshop. It feels insane. It's just mind-blowing that, you know, that so many of you actually tune in and watch, but also subscribe, comment, hit like, you know, and I've got 27 or 28 channel members now, which is, you know, doesn't make sense to me. So thank you to everyone. Only 95,000 subscribers to go before I get that silver play button, but I don't think that'll ever happen. But you never know, so thank you everyone. It does mean a lot that you will watch this stuff. Hopefully I'm putting out stuff that you enjoy and that you find interesting. As you all know, and I say this a lot, I try and do everything different to all the other app techs on YouTube, mainly because I think of myself, well, I am an app builder more over than a repairer. So my stuff is different, and you lot seem to get that and enjoy it. So thank you. It really does mean a lot. And because all of you comment so much, I get to do these Q&A videos once a week, which I really enjoy doing because I get to answer things in ways and explain things in ways that other techs don't. So yeah, hopefully you lot get something out of it as well. Anyway, we'll start with channel member My Name Was Techo, who comments a lot. Welcome. Great video as always. This was on the part 11 of the Christmas special, the Baseman 135 rebuild, the one where I actually fired it up on the bench. He says, having really enjoyed seeing the entire process to date and look forward to seeing the fully finished article. Despite watching your excellent content for a while, it always amazes me how little wall current is required to produce such high volume amps. 128 watts clean and less than an amp from the wall. Yeah, I think that was right. It may have been slightly over an amp. I can't remember now. When we get this thing fired back up finally and completed, we'll take all those measurements, and then we've got that good data set. So we know exactly what it should be, which is important actually, because once you've got that data set, if anything happens down the line, you can look back and say, well, this is what it was when it was new. This is what it should be. Something's changed. And it's easy to find that when you've got that information to hand. So yeah. But yeah, I mean, valve amps aren't efficient. You know, that it draws far more watts out the wall than it puts out in audio power. Off the top of my head, I can't remember what the ratio often is, but it's quite often that you can draw 2 or 3 times the amount of power from the wall than you create. So whatever that works out to be, what is it, 30 to 40% or something like that? I can't remember now. Anyway, yeah, but yeah, great question. So I'm just working on the Abbott 5E3. Now I'm a little confused by this amp, and I'll probably go into more detail in some other clips. But essentially, I think somebody else has been in this, because a lot of the work in here isn't Eli's. Things have been done in different ways to how he's done them, and I've been through a lot of his amps now. Things have been changed. The grounding scheme was completely weird, and I think that's where most of that noise was coming from. So I put it back to a more conventional, optimized grounding scheme for a 5v3. I couldn't get it perfect. I had to pull the board out to check things underneath, and the condition of some of the turret bases is awful. So I don't know what's going on there. One of the reasons I don't like turrets. But yeah, so anyway, the board's back in. I've improved the grounding scheme. I'm just working on the power supply, bits and pieces, stuff like that. Yeah, but we'll talk about that more in some other clips. Anyway, next question was from Mark Smith, who says, what are your thoughts on the new Mesa Boogie, and why would they use a dual rectifier? Really enjoy your work in the black magic of valve amplification. Well, welcome to the channel, Mark. Thank you for your question. What are my thoughts on the new Mesa Boogies? Well, I haven't seen inside any of the new Gibson built ones. From the outside, they look the same. They probably sound the same or very similar. Like most amp techs now, I won't touch Mesa Boogies. I'm not an authorised repair centre. Getting parts is more difficult, especially since the distributor in the UK changed. Now there's no technical support for non-authorised repair centres. They're a pain to work on anyway, and it's just a nightmare. I'm just not interested. So if people contact me and say, would I take one on? It's very rare that I do. I'll take on the early stuff. Quite happy to do that, but the more modern stuff, no. Take it to an authorised repair centre. They can get the parts. They can deal with all the problems and all that stuff. But yeah, I'm just not interested. Why would they use a dual rectifier? Well, using dual rectifiers, that means, well, I mean, it goes back to, was it the big box twin? No, it was the small box Tweed twin, wasn't it? That was the first one that had the 2 rectifier valves, I think. Simply because it used 2 5U4s, didn't it? Because one couldn't supply enough current for the amplifier, so they simply just put 2 in parallel. Yeah, that's all it is. The problem is it sounds good as a marketing thing, so I think that when Mesa took it on, they used that as a selling point. But yeah, it just, I mean, I can't actually remember. This is how much I don't look into Mesas that much. Does the dual rectifier in those amps mean that it's got both solid state and valve and you can switch between the two? Probably, that sounds about right to me. But the original dual rectifier amps, the old Fender Tweeds, just had 2 valves in parallel. Yeah, so there you go. Really enjoy your work in the black magic of valve amplification. Yeah, me too. I love it. It's great. Nothing better than turning up every day and getting to work on stuff like this. Yeah, I love it. Absolutely love it. So, can't get me to do anything else. The bits have arrived for the 18-watt clone that was in a couple of videos ago. The one that has got various issues, and the customer was willing to spend a good bit of money on it to get it sounding really, really good. So just to recap, the power transformer puts out far too much voltage. So the recommendation was to get, obviously, a nice transformer. And I've had this one wound for me by Modulus. Very, very nice to my specs. which will run everything in this amp exactly where it should be to make an 18 watt sound like an 18 watt. If you don't remember, this sounds more like a hot rodded Vox than it does an 18 watt plexi. So, you know, I've got to get this thing where it needs to be. We then also discussed replacing the output transformer at the same time. So Modulus has done a matching output transformer for this amp as well. The two EL84 output valves completely toast, so we've got a match set there to go in, and we're going to beef up the filtering in the amp with some new filter caps. So I'm not going to get onto it in this video, but hopefully you should see some progress on it on Sunday's video, and then hopefully finished by next week. But we'll see. It's step one in a long process in trying to get this amp to be as good as it can be, and to make the most of those two Celestian golds that he's got in that cabinet. Uncle Daddy says, nice searing and hearing that Princeton. Thanks. That's Ainsley's, was a 67, wasn't it? The one with the Deluxe Reverb power transformer. With 460 volts DC at the first node, would you need to be concerned about the capacitor ratings? Yes, you would. I note the original schematic asks for 400 volt rated caps as a minimum, yet has 420 volts at the first node. So 460 volts has to be pushing it a bit. Yep, you're absolutely right. And as you will see from that footage, and as I pointed out, the caps had been replaced in that amp, and the first node had a 500 volt rated cap in there. But yes, you're absolutely right. Capacitors will often have, I've got one here, maybe, I've got one here. Yeah, so here's an old F&T. This is an 80 microfarad, and it's rated at 450 volts. Now, you'll have to check the data sheet. Can you see that? Where's your camera? There it is. You'll have to check the data sheet as to whether that's the maximum voltage or its working voltage. On old caps, they used to print both of them on there, so you'd know. It might say, for example, 500 volt max, but 400 volt working. So you'd have a peak for, you could go up to 500 for a short amount of time on turn on and stuff like that. But yeah, you do have to check your caps before you do stuff like that. So, but in that amp, it's got a 500 volt cap. So yeah, that one was all good. Right, the Abbott 5E3. So if you remember from last time, we gave this thing a check out. We wanted to see what it was doing, what it wasn't doing. And during our bench test, we noticed that it had an extremely loud hum when you turned all the controls up. And we measured that. It was 150 hertz, so the third harmonic of the mains frequency. And it was measuring at negative 47.6 dB on the app that I use. All I've done so far with this amp is I've reactivated the VVR, so I've wired that back in. I've added a B+ fuse. I've reconfigured the ground, so the safety earth now has its own dedicated point. None of the transformer bolts are used as a ground now. I've got a mini star ground up in here. Will you zoom? You want to show you? It's just in there. Might be difficult to see, but there's one there. The way this amp was wired was all of the grounds were tied together under the board and then grounded to a transformer bolt. What I've done now is I've separated the grounds. So the way I've done it is you've got these three filter caps here. So you've got your cathode resistor and bypass cap, the reservoir cap and the screen cap all on one ground, and they go off to our mini star ground up here. The preamp filter is grounded over by the inputs along with the rest of the preamp grounds, and the pots are no longer grounded to themselves. They are now grounded. I've got a little bus bar in, and that grounds to everything else there. So all I've done is separated the preamp ground from the power ground. put the VVR in. Standby switch has now got a bypass resistor on it, so there's no surge when you flick it on. There's always going to be a trickle current flowing in the off position, and I'll show you how that works. VVR's back in, and I have, just for the time being, it had two 1K resistors in parallel for 500K. I've just replaced those with a 470 ohm resistor for the time being, and then we're going to adjust that accordingly. But I want to show you the results. So here's the same app that I used last week. All right, in the same position, I want to show you where we went. I'll put on the screen now, here, what it looked like last week. All right, so you can see what happened when I had the tone control on maximum, which now is the case. And I turned up the normal channel volume. I won't talk, and you'll be able to see the difference in what sort of hum reduction I've achieved just by getting the grounding scheme right. Here we go. Incredible. No magic, no clever tricks or anything like that. Just get your grounding scheme right and you get a massive reduction in hum. So I think it was negative 47, so we'll call it negative 48. And now we're down at negative 78. So call that a 30 dB reduction in hum. Sure, I should turn that control up to measure it properly, shouldn't I? Let's do that one again. Yeah, just under a 30 dB reduction in hum. Haven't replaced any components. All I've done is sorted the grounding scheme out. And this is why having a good understanding of grounding schemes is important when you build an amplifier. Because if you don't get it right, it gets noisy. Don't just copy what someone does on the internet. Learn it, understand it, read the books. Understand the difference between audio ground and power ground. Which part of the circuit need to ground where and how you need to run them and what you want to do and what you don't want to do. You've got to understand it all, otherwise you end up with a noisy amp. So that's all I've had to do on this so far. Let's measure some B+, shall we? So if I just measure on the first node, currently we've got 390 volts on the first node, which is, depending if you're going for a classic 5E3 or not, it's arguably slightly high, but it's not the end of the world. VVR's in maximum voltage at the moment, so I'll just scale it down and you can see how that drops. So it's dropped it down to roughly 1/10 of the voltage. Bring it back up. Right, let's inject a signal. As always, 1 kilohertz, 150 millivolt sine wave. There's the scope. So I'm into the normal channel. We'll bring it up, we'll bring it up. 5E3 should be 12 watts into 8 ohms, so we're looking for roughly Well, 10 volts output will be 12.5 watts. So there, giving us 8.2 volts. And there's already quite a bit of crossover distortion. So it's doing somewhere between 8 and 9 watts. To get a clean, to get it no crossover distortion, we're down there at 7, which is at 6.1 watts. So it's still down on power. So now we need to investigate what's going on there. We'll just check the other channel. Similar thing. Okay. I'll go back to 0. Let's check some voltages. So on need to get some paper. Okay, so let's come back down to here so you can see what I'm doing. So as the amp currently is, right, we need voltage at the anode to cathode, voltage at the screen to cathode, resistance of the cathode, and voltage drop across the cathode to ground. Okay, so the voltage drop across the cathode to ground is the easy one. We're already connected to ground with my meter. So across that resistor, 24.5 volts. Okay, now I need to move my common to the cathode. And on the anodes, we've got 361 on that side, 361 on that side. The screens, there we go. Can you see? 331. Okay, turn the amp off. Discharge cable, easiest way to do it. It's got a 1K resistor in there, 1K 1 watt resistor, and I simply go off one of the preamps here, preamp plates, and that'll just discharge the amp. Okay, resistance mode. Should be 470 ohms. 466. 466 ohms. Okay, so the first thing we need to know is the amount of current running through that cathode resistor, which is the total current for both valves. And the easiest way to do that is voltage, 24.5, divided by resistance, 466. Means we've got 0.0525 amps divided by 2 means we've got 26.3 milliamps per valve, times that figure by our anode to cathode voltage, 361, means we're currently running at 9.5 watts divided by 12, because that's the maximum. We're currently running at 79%. So we are biased cool, which partially explains the crossover distortion, but for a 5E3, my preference is that these two numbers are closer together. If I would like no more, this is personal preference, than a 10 volt difference. Okay, As I mentioned last time, the screen stopper in this amp, this green one down here that you can see, on the original 5E3s, it's a 5,000 ohm resistor, 5K. The modern E12 value for that is a 4K7, but this amp's has gone the other way with a 5K6. So the builder has deliberately dropped more screen voltage. So what we're going to do is swap that out for a 4K7. Go back in, check that the difference between these two has reduced. That'd be nice. And then we can start messing around with that value there. Now that's a 470 ohm. The next E12 value down will be 390. So that's the one that's going to go in, and I've got one. If not, it'll be 330, and we'll go from there. Edward says, hello, I've got a question. I'm having a hard time dialing in my solder station. It's either too little heat or too much heat. What do you usually set your solder station for eyelets, turrets and chassis grounds? Well, there are two things you need to consider. Well, three. We'll talk about three things to consider. No, four things. Four things you need to consider. First of all is you need to look at the datasheet for the solder that you're using. Make sure you understand what its melting temperatures are, what the requirements are for it. They're all different, and you would adjust accordingly. The second thing is what tip your soldering iron has. Now, I always use a 3.2mm chisel tip. That gives me a nice wide working area with a nice wide, so I get a nice wide point of contact surface area for heat transfer. I'm going to talk about heat transfer. Every tech does this different, and you're constantly adjusting because you have to find out what works well. For guitar amp work, I use a 60-watt iron for most of the jobs in the amplifier. An easy way to think of it, and I'll caveat this by saying there's more to it than this. You can go into more detail, but as a brief overview, an iron will have two properties that we're interested in. One is the actual temperature that you set it to, and a good rule of thumb is 150 degrees Celsius above the melting temperature of the solder. So whatever that, look at the melting temperature of the solder, go 150 degrees Celsius higher than that. That's generally what you want to set your iron for. Again, that varies. You might find you need to push that even more or drop it even further. The second one is the wattage of the iron, and the easiest way to think about what the wattage of the iron means is how efficient it is at transferring the heat to the component and then maintaining the temperature while it does that. Obviously the tip of this iron now, mine is at 363 degrees Celsius. Now, as I touch that to a cold component, you're going to get some heat transfer, and therefore the temperature of the tip is going to drop. And the iron is then going to add more power and add more heat, so the station is going to add more heat to the tip to try and keep that temperature the same. The higher the wattage rating of the iron, the more efficiently it can do that, and therefore more efficiently it can transfer the heat to the component. Got it? Makes sense. So, and I find that a 60-watt iron really is the minimum you need. You can get away with a 40-watt iron, but 60-watt irons they have that kind of headroom, that extra capacity that just makes everything easier. Often, if you have a soldering station that's 40 watts and you start soldering, when you first touch a component, you'll see the tip temperature drop and then come back up. Where with this, generally it stays pretty much the same. So you need to really get yourself a minimum of a 60-watt iron if you're struggling with stuff. If it's too much heat, well then you need to drop the temperature. Yeah, right? If it's too little heat, you need to up the wattage of the iron so it can counteract that temperature drop that you get. It's the same principle as when you're cooking a steak on a griddle, right? As you drop a cold steak into a hot pan, the temperature of the pan drops. and then it comes back up. And it's how quickly you can get that temperature back up that will affect how well these things do. So that I'm normally at 363, 60 watt iron, 3.2 millimeter chisel tip for nearly every single job in an amplifier. Now, all my chassis grounds I do to terminal points anyway, which my iron can handle. If I'm soldering directly to a chassis, like working on an old fender, for example, I've got a big 200 watt iron for those jobs, because that can apply a lot of heat very quickly and it can maintain that temperature drop. Obviously a chassis is a big heat sink, so it's kind of draw away as much temperature as it can. So you need to keep applying that hot temperature. So it's trial and error, really. We worked out that 363 degrees Celsius with our setup, with the solder that we use. Remember, it's for all the builds I have to use lead-free solder, but I use the same settings when I'm using leaded solder, to be honest. It just flows even quicker. Fantastic. But yeah, it's one of those things you keep working on it and you dial it in and you work it out. And we actually spent a lot of time doing that, trying to find the optimum for our setup. But as a rough rule of thumb, as I said, find the melting point of your solder, go 150 degrees Celsius higher than that. That's your starting temperature for your iron, and then adjust it from there. Okay, skip forward a bit. I have swapped out the 5K6 for 4K7, and I've also swapped out the cathode resistor for a 390 ohm. It's actually 386, but close enough. Here are the numbers. So we've now ended up with a 25-26 volt difference between our anode and screens, and we're now running at 97% up from 79, so huge difference. On the scope, we're now getting 9 that down a bit. We're getting 9 volts output now, which is 10 watts, so we've gained some. So do I go for 330 ohms on the cathode resistor, or do we leave it at that nice, safe, conservative point? So these are 12 watt 6v6s. If we put a set of 14 watters in, they're going to be higher. So the bias is going to be even cooler. So, but if I bias it for a 14 watt set, then 12 watts are going to be over. So I think where it is now is a nice conservative place for the amp to be. I think that's a good place for it to be. It's running just on the good side of hot, moderately hot, not lukewarm, warmer than that, but not hot. Yeah, seems to be running great. Tell you what we should do though, is turn the VVR down. So the amp's now running at 9 volts output. If we scale it back to 50%, we get quite a drop there, 2.6. That's down to 1 watt. We'll bring it back up again. You can see what scaling it down does. It would be better if we just scaled the output stage. But anyway, that's what it does. That's what it does. So now I'm happy with the amp. I'm happy that it's got a good baseline. It's running where it should be. And I need to speak to the customer to decide whether he wants me to do any tonal improvements to the amp. So, for example, do you remember all of the coupling caps are not 5E3 values? The builders used smaller values across the board apart from the phase inverter coupling cap, which is still 22 nanofarad, just to try and tighten this thing up. You know, 5v3s can suffer from quite a flubby bottom end and depending on the speaker you use, you can make that even worse, or you can improve it. So I personally, having play tested this, think it sounds great. So I would leave it as it is, but it's up to the owner what he wants me to do. He's only paying for 2 hours on this, and that's what I've spent on it now. So if he wants me to go further, it's going to cost him more. But my recommendation would be leave it as it is. It's running great. It sounds great. It's putting out, almost 12 watts, depending at which point you measure it. But it's nice and cool. It runs great. Hasn't had to replace any components inside, other than 1, 2. That's it. So yeah, cool. I think we're going to call this one complete, unless the customer gives me permission to go ahead further. Well, that's it then, guys. Thank you very much for watching once again. As always, you know the drill. Please give this video a thumbs up. All your comments and questions down below. Subscribe if you haven't already. Hit the notification bell so you know when new videos are coming out. If you're feeling really generous, you can join the channel like these guys have. And I will catch you all at the next one.